This video is for Algebra Section 6.1, Solving Inequalities by Addition and Subtraction. Our learning goal is written up there. Says the learner will apply knowledge of inequalities to solve them using addition and subtraction. So basically you should be able to solve these equations using inverse operations with addition and subtraction. Our vocabulary terms says addition property of inequality. We have already done the addition property of equality, so you should remember that was when you could add something to both sides. So if I had something like x minus 4 equals 12, you could have added 4 to both sides. That was using addition property of equality because there was an equal sign. Addition property of inequality is basically the same thing, except that it's going to have a greater than sign or a less than sign. Okay, so I would have something bigger than something. Then if I add c to both sides, it's still true, is what they're saying. So if I had an example, if I had x minus 4 is greater than 12, same thing, I could add 4 to both sides. Those would cancel. I would have x is greater than 16. Okay, and those are the types of problems that you'll be doing in this section. Subtraction property of inequality is very similar. Again, property of equality we had before would have been something like x plus 2 equals 8. You would have subtracted 2 on both sides and got x equals 6. This is the same thing except that it's a less than sign or a greater than sign. Okay, so they're not equal. So I would have had something like x plus 2 is less than 8. And I could subtract 2 from both sides, and I would get x is less than 6. Okay. Some prerequisite skills that you need. You need to know the greater than sign looks like that. The less than sign looks like that. Greater than or equal to is greater than or equal to. Less than or equal to is less than or equal to. You should have learned those before, and you'll need them again in this lesson, so you need to know which one is which. Also, basic solving equations. If you can't solve equations, you won't be able to solve inequalities. They're the same basic work, so you need to be able to do both those things. All right, and we will move on to doing the odds on the study guide. All right, I'm going to go ahead and get a new page. So if I look at number 1 on the study guide, it says t minus 12 is greater than or equal to 16. All right, if this is an equation, I would want to add 12 to both sides. You'd do the same thing with an inequality. So t is greater than or equal to 28. They also ask you to check your solution. To check it, I have to pick a number that fits the statement. So it says t is greater than or equal to 28. So I want to pick a number that's greater than or equal to 28. I could do 28 because it's equal to it. That works. So 28 minus 12 is greater than or equal to 16. 28 minus 12 is 16. Is 16 greater than or equal to 16? Yeah, it's equal, so that counts. So that means my answer was correct. They also ask you to graph it on a number line. So on your number line, it says it's anything greater than or equal to 28. So I'm just going to draw the numbers that are close to 28. I'm going to do 27, 27, 28, and 29. You have the graph already drawn on your page. At 28, it could be greater than or equal, so it needs to include 28. So I'm going to put a solid dot, and it's everything bigger, so it's going to go to the right. And if you're not real sure about whether it's going to go to the right or the left, if you look at this sign, it points to the right, so you shade to the right. All right, let's do number 3. Number 3, 6 is less than or equal to g minus 3. Same thing, if this was an equation, I would want to add 3, so I do the same thing. I'm going to get 9 is less than or equal to g. We don't want it that way. We want to rearrange it so the variable is on the left. So I'm going to move my g here, keeping in mind this right here was trying to eat the g, right? If it's the mouth, it's eating the g. You have to keep it the same way. So it's going to flip around to follow that g, and the 9 is going to go on the other side. And again, I need to check it, so I need a number bigger than or equal to 9. I'm going to choose to use 9. All right, so if I plug in 9 where g was, I'm going to have 6 is less than or equal to 9 minus 3. I just replaced g with 9. 9 minus 3 is 6. So that's where I got that. Keep everything else, bring it down. Is 6 less than or equal to 6? It's equal, so yeah, that works. Circle my answer. Notice how my work is nice and organized. It's easy to tell where my answer is, easy to tell where my check is. And then I'm going to have my number line. And again, you have the number line already. I'm just going to put the numbers around 9. And we are including 9 again, so it's going to be a dot. And that arrow, when you look at the one that's written the right way, it's pointing to the right, and it's talking about numbers bigger than 9. To the right is where the numbers bigger than 9 are. So shade that in. All right, let's move on. Number 5. So I have negative 12 is greater than negative 12 plus y. Again, you want to get y by itself, so I'm going to add 12 to both sides to get that to go away. And in this case, those will cancel like I want, but so do these. So I get 0 over here is greater than y. Rewrite it, moving it. It's still trying to eat the 0, so put the 0 in the right place. And then I need to check it by saying y is less than 0. So what's a number less than 0? Negative 1. Negative 1 is less than 0, so I can plug it in. So I'm going to replace my y with negative 1. And that will give me negative 12 plus negative 1 is negative 13. And negative 12 is greater than negative 13. That's true, so it works. So this is my answer. Okay, and this is the last one I also have to do a number line for. And it's negative 1 and 0 and 1, and again, they already gave you that, so you don't really need to do that. At 0, this time it's not including 0, it's less than 0. So I need to put a circle because I don't want to include 0. It's not a dot this time, it's a circle, and it's pointing to the left, and it means numbers smaller than 0, so it's going to go to the left. Anything smaller than 0 is going to be shaded. I'm going to put an arrow to represent that. Number 7. When we get to number 7, we don't have to do the number line anymore. We still have to do everything else the same though. And they get a little bit more complicated, you will notice. Okay, if this was an equation, if it was an equal sign here, I would want to get my x's together. So I would probably want to add 4x to both sides. Negative 3 and positive 4 gives me positive 1. Remember, we don't want to write the 1, we just want to write x. That means 1x. Keep that sign and bring the 8 down. The x is canceled. So x is less than or equal to 8. Check my answer by plugging in something less than or equal to 8. When you're doing this, you can pick any number less than 8. So try to pick something that's easy. In this case, since I have to multiply it by these other numbers and then subtract it, I'm going to pick 0 because it'll make everything very simple. Negative 3 times 0 is less than or equal to 8 minus 4 times 0. So I changed all my x's to zeros. So I get 0 is less than or equal to 8 because that's 0, so it doesn't matter. 0 is less than 8, so that works. So my answer was correct. Number 9, same idea. We have negative 8k minus 12 is less than negative 9k. So I want to get my k's to go over there with the other k's. So I would say I want to add 8k. Negative 9k plus 8k is going to be negative k. And this is where you're going to have to add something to your notes that you don't actually learn until the next section. But because of the way we happen to solve this one, you'll need it. So you might want to write it down now. Basically, I would put a big star because this is very important. Anytime you multiply or divide by a negative number, your less than or greater than sign will flip. you have to flip it. So right here, I need to get k by itself, so I'm going to either multiply or divide by -1. So when I multiply this by -1 and multiply this by -1, I get 12 here, I get positive k here, but that sign has to flip. And the reason that you have to do that, if I just picked regular numbers, like 5 is less than 8, that's true. 5 is less than 8. If I multiplied them by -1, I would have -5 is less than -8. Is that true? No, -5 is bigger than -8. So I had to flip my sign to make it true. So every time you do that, you have to flip the sign so that it's true. Okay? And again, you'll need to check your answer. So I need to rewrite this so that it says k is less than 12 first. Write it the other way. If k is less than 12, I can pick anything less than 12. Another time, I can pick an easy number. I can use 0. And I'm going to put in -8 times 0 minus 12 is less than -9 times 0. That's 0, so I get -12 is less than 0. Yes, that's true. So my answer was correct. Moving on to number 11. On number 11, we have some fractions. We have z minus 1/3 is less than or equal to 4/3. The way that I've been teaching you to do fractions, we multiply by whatever the common denominator is to get rid of the fractions so we don't even have to deal with them. So in this case, my common denominator would be 3. So I'm going to multiply everything in there by 3. So 3 times z is 3z minus 3 times 1 divided by 3 is 1, less than or equal to sign. 3 times 4 divided by 3 is 4. Now I have something that looks a little bit easier to deal with. So I could add 1 to both sides to get my numbers all over the right. So I have 3z is less than or equal to 5. And then I can divide by 3. And I did tell you the title was using addition and subtraction, so you shouldn't have to be multiplying or dividing. And you wouldn't have to if you wanted to add 1/3 to both sides. You can do it that way. We've tried to get rid of fractions for a lot of students so that it makes it a little bit easier. It's up to you. You get the same answer. So I would have got z is less than or equal to 5/3. Well, 5/3 is 1 2/3, right? So I can pick anything smaller than 1 2/3. And I know I'm going to have to subtract 1/3 from it. Or I could even pick 5/3. I'm going to use 4/3 because that's smaller. Minus 1/3 less than or equal to 4/3. Keep in mind, I might want to use something with thirds because then they're all common denominators. It's very simple to solve. So 4 minus 1 gives me 3, and 3/3 is less than or equal to 4/3. Even if I don't convert that to a 1, you should know that that's true. So my answer was correct. On to number 13. For 13 and 15, they ask you to do 4 things. You need to be very specific and read those directions so that you do all 4 things. So the first thing they ask you to do is define a variable. So I'm going to define my variable. All that means, let whatever letter you pick, let x be a number. So that means my variable is going to be x. That's defining a variable. Write the inequality. So my inequality, I have to read it and write it with my x. So it says a number, we said a number was x, right? So I put x decreased by 4, decrease means minus 4, is less than 14. It's less than 14. All right, so then I would have to solve that. That was the next step, is to solve. So I'm going to add 4 to both sides. And x is less than 18. And then it does say I have to check my solution. So I have to pick a number less than 18 and see if it works. So let's say 17. 17 minus 4 is less than 14. That gives me 3. Sorry, that gives me 13. Is less than 14. Yeah, that's true. So that means my answer was correct. Make sure all 4 of those things are able to be found so that you have all 4 things answered. So 1, 2, 3, 4 things. I defined it, I wrote the inequality, I solved it, and I checked it. All right, moving on to number 15. Number 15, 40, sorry, I didn't define my variable first. So I'm going to use the same one. You can use whatever letter you want. So let x be a number. And it says 40 is no greater. Well, I know I start with 40. Is no greater. Let's think about what that means. Well, if I wanted something to be no greater than 5, it means it's going to be something smaller than 5. So that should mean less than or equal to, right? No greater should be less than or equal to. Then the difference of a number and 2. So the difference of a number and 2, that means x minus 2. All right, and then to solve that, so that was our inequality again. And then we would solve it by adding 2. Get 42 is less than or equal to x. Rewrite it so the variable is on the left. You always need to do that. So that was our solving. We solved. And then we have to check it. We have to plug in a number that is greater than or equal to 42. So if I plug in something, let's say 43. So 40 is less than or equal to, replace x with 43 minus 2. 40 is less than or equal to 41. That's true, so my statement is true. And make sure when you're doing the check, don't get confused by trying to use the answer in there. That's how you pick what number to use, but you don't use that to set it up. You need to go back to the original statement and just rewrite it, replacing your variable with whatever number you chose to plug in. So make sure you're doing the checks correctly. Okay, and that was the first page of that section. Moving on to the next page, which should be the subtraction problems. So on that page, we have number 1 is t plus 12 greater than or equal to 8. I got to get t by itself. So I want to subtract 12 from both sides. So t is greater than or equal to negative 4. All right, so that means I need to pick a number that is greater than or equal to negative 4. The easiest one is probably 0. So I'm going to replace in this original statement, replace t with 0 and bring everything else from the original statement. And 12 is greater than or equal to 8. That is true, so that means my answer works. And this is another one you had to put on the number line. So you should have negative 5, negative 4, negative 3. It is including the negative 4, so I'm going to put a dot on negative 4, and it points to the right because it's talking about the numbers greater, so they're over here. And that's it. Number 3. Number 3 says 16 is less than or equal to h plus 9. And we want to get h by itself, so I want to subtract the 9 to make it move over here. 16 minus 9 should be 7. All right, and I got to rewrite it so that my h is on the correct side. So h is greater than or equal to 7. So plug in something bigger than 7. How about 8? Could be equal to 7 too. You could use 7. 16 is less than or equal to 8 plus 9. You should know 8 plus 9 is 17. 16 less than or equal to 17? Yeah, that's true. So my answer was correct. I'm going to put it on a number line. So again, we needed 7, so we would have probably 6, 7, and 8 right around it. And it is including the 7, so it's going to be a dot. And it's going to go to the right to the numbers that are bigger than 7. That's it. Moving to number 5. Number 5, you have 3r plus 6 is greater than 4r. So I want to get all my r's together. Since we already have r's on both sides, but there's a 6 here, I probably want to move these r's over there. I'm going to say I want to subtract these 3 r's from both sides. So 6 is greater than 4 minus 3 is 1. Don't write the 1, just put r. And then I need to flip it around so my variable is on the left, so r. And it's got to stay pointing toward the right thing, so it's got to still eat the 6. Put it that way. Okay, and you also had to put that one on the, oops, sorry, I forgot to check it. Excuse me. So I need to pick a number less than 6. You could pick 0 if you want. Be more creative. You could pick 5. You pick whatever you want that's smaller than 6. So I'm going to use 5 just for fun. And so you can see why I might want to pick 0. So I do have to do a little bit more work when I pick a different number. It still should work. So 15 plus 6 is 21. 21 is greater than 20. That's true. So my answer works. Then I need to put it on the number line. So we should have 5, 6, and 7. It's not including the 6 because there's no equal to. So I put an open circle, and it's pointing to the left, the number's smaller. So I'm going to fill in to the left. And hopefully your shading is much better than mine. All right, number 7. Number 7, we have r plus 1/4 greater than 3/8. And again, this is a case where I would say we don't like to work with the fractions because we make more mistakes that way. So we're going to multiply everything in here by the greatest common, by the common denominator, which would be, if you have a 4 and an 8, your least common denominator, there we go, should be 8. So you want to use 8. So 8 times r is 8r. 8 times 1 is 8 divided by 4 is 2, greater than 8 divided by 8 is 1 times 3 is 3. Keep in mind when you're doing that you can either divide or multiply first. Doesn't matter as long as you divide by the bottom number and multiply by the top. Now it's a little bit easier for us to solve. So we have to subtract 2 from both sides. So 8r is greater than 1. We want to get r by itself, so divide by 8. And r is greater than 1/8. So we need a number bigger than 1/8. A very easy one to use might be 1, except that if we look at this, we could just put everything into eighths for the check. It would make things easier. So I might use 3/8. 3/8 is bigger, so we could use that. So I'm going to replace r with 3/8 plus 1/4. I would probably convert to eighths at the same time. That's 2/8. You should know that. Greater than 3/8. Well, that's 5/8. And that is greater than 3/8. So that's true. That means my answer worked. Moving to number 9. On number 9, we have 9k plus 12 is greater than 8k. We want to get my k's all together, so I'm going to subtract 9k's. Those will cancel. I get 12 is greater than negative k. Well, I could rewrite it now, move my negative k over here, and make sure my arrow is still pointing to the right numbers. But that's negative k, that's not my answer yet. I still need to multiply everything in here by negative 1 to get that negative to go away. So k and negative 12, and remember what happens every time you multiply or divide by a negative number, this sign has got to flip. So you flip it the other way. So k is greater than or equal to negative 12. All right. So I need to pick a number bigger than or equal, sorry, greater than, not greater than or equal to, just greater than negative 12. I'm going to use 0. So 9 times 0 plus 12 is greater than 8 times 0. Again, plugging those zeros in where k was in the original statement. So that's 0 plus 12 is greater than 0. 12 is greater than 0. That's true. So that means my answer works. Number 11. 4y, oops, 4y is less than 5y plus 14. So I want to get my y's over here. So minus 5y. That gives me negative y is less than 14. Again, we don't want that negative, so we're going to multiply everything in here by negative 1, which gives me y and negative 14. And if you multiply by a negative, every time you have to flip the sign. So y is greater than negative 14. So again, I need a number bigger than negative 14. I'm going to choose 0 because it makes everything simple. So 4 times 0 is less than 5 times 0 plus 14. Again, plugging those into the original statement. That's 0 is less than 0 plus 14. 0 is less than 14. That is true, which means my answer works. Moving on to number 13. Number 13. Number 13 is, again, you have to define the variable. So I'm going to continue to use x. You can use whatever letter you want. Let x be a number. And says the sum of a number, sum means adding, so the sum of a number and 8, so x plus 8, is less than 12. So to solve that, I would have to subtract the 8, and I would get x is less than 4. Pick a number less than 4 so you can check it. So 3. 3 plus 8 is less than 12. 11 is less than 12. That's true. So my answer works. Number 15 is the last one in this lesson that I'm going to do. So again, define my variable. Let x be a number. So it says the sum of a number and 6. Again, that's adding. So a number plus 6 is greater than or equal to negative 4. I would subtract 6 to get the 6 over with the other numbers. So x is greater than or equal to negative 10. So I need to pick something greater than or equal to negative 10. I'm going to use negative 10. Plug them into the original equation. Negative 10 plus 6 is negative 4. Oops. And that is greater than or equal to negative 4 because it is equal. So that means my answer was correct. And that is the end of lesson 6.1.